guys, so this is your last video for this lesson. I'll try to keep it nice and quick. There is something that we like to call solutions in the math world. And a solution is kind of like an answer. It is what satisfies an equation. We'll talk about them more later on in this year. But for right now, it's good for you to know it so that you guys know what to do when you run across certain situations with algebra tiles. So one of the situations you guys ran across is if you did B or C, I think they both did it. You'd run across this solution, which gives you 2 equals -2. Now, I'm hoping that in your head you're thinking, gee, I'm pretty sure 2 doesn't equal -2. Because that's like saying that somebody with $2 is the same as someone who owes someone $2. That's not really the case. So that is what we call a no solution. You can kind of think of it as there's no actual answer, except that no solution is in fact the answer. Solutions are what make an equation true. Remember, we start every equation by saying that this side, the left side, and the right side are equal to each other, right? And then we have to figure out what makes them equal. So what number put in for the value of x would make both sides equal? Normally it comes out to be 2 or 3 or whatever it is, and that makes both sides equal. But only that value. If I was to put in a different value like 1 or 10 or something that was not value x equals, it wouldn't be true. They would be not equal. So a solution is what satisfies an equation. It makes an equation true. In this case, nothing I could put in for x or y or any variable out there would make this equation true. This equation has absolutely no solution that would satisfy it. Okay? Nothing will make it happy. So this is a no solution. Whenever you end up with the variables all gone and the numbers, the units on either side don't match, so 2 and -2, it's a no solution problem. Now there is one where all the variables go away, and it's called an all solutions problem. I'm glitching here for some reason. Okay. This is called a, This is called an all solutions problem. If you end up with both numbers on either side being the exact same, so in this case 2 and 2, it could be 10 and 10, it could be -2 and -2, right? Normally with working with algebra tiles, what would you do with these guys? What move would get rid of them? Move it, right? Move it would have gotten rid of all these tiles, so it's really you have 0 equals 0. Is that true? Yeah, 0 equals 0. If you have no money and someone else has no money, you both have the same amount of money. No money, right? So 0 equals 0 is true. In this case, we say that this equation has all solutions. I could put any number in for x or y, and it would be true. They would both equal each other. That's what we mean by all solutions. I can literally use any number in the entire universe, no matter how small or how big, and it will make that equation true. That equation will be happy. So that's a no solutions problem. Now, just to give you a name for what you guys have been working with, let's say you end up with something like this, right? Which is how most of your problems will end up. This is called a one solution problem. If my computer will stop glitching on me, solution, a one solution problem, because there's one number, in this case 2, that makes this equation equal. It makes it true. I like to say it makes it happy. There is one number that makes this equation happy, okay? And that's what we do when we talk about solutions. So today you are going to run into, in the next couple practice problems I give you in Nearpod, you're going to run into a no solutions, an all solutions, and several one solutions. So I want you to be able to name those correctly. Remember, a No solution is the things that don't actually equal each other, like 2 equals -2, not true. And all solutions is 0 equals 0 or 2 equals 0. If it's true, it's in all solutions. And then a one solution is when you have only one thing that will make that equation happy. Okay, if you guys have any questions, please email me or Ms. Schmidt, and we would love to